Yes, class, is this audible? Yes, hello? Salman, Samaira, Sara.
Yes, ma'am. Sorry.
It's audible? All right. Shravya, so you're back? All your exams are over?
Yes, ma'am.
Oh. And Zaid, what about you? You will continue in this batch only?
Yes.
All right. So, Zaid, what about the second chapter? Will you take backup in the other batch or that is done?
I am doing that myself.
Okay, then if you have any doubts, then ask me. Or you can take the backup also, at least for capacitance, because
Yes,
potential you have already done. So at least take the backup of capacitance in that batch. It will take hardly 2 or 3 classes for you to attend extra. Otherwise you'll be able to manage from this. All right.
Yes.
Okay. Now, in the last class, we had started with current electricity, where we have first understood what was electric current. So, just a quick recap of what we have done. Electric current was the flow of charges per unit time. So if you have to calculate the average current, you write it as delta Q by delta T. Or if when you have to find the current at a particular interval, not an interval, at a particular time, for example, T is equal to 2 seconds, T is equal to 3 seconds at a particular time, then you take out the instantaneous current. Average current you have to use whenever you have a time interval. For example, 0 to 3 seconds, 4 to 5 seconds. Then you use delta Q by delta T. If you have to calculate the current at a particular time, be it infinitesimal small, 0.0001, then you calculate the instantaneous current. Then we had done the drift velocity. So drift velocity was the average velocity of all the electrons that were drifting towards the positive terminal under the application of electric field. So we had derived it and it came out to be minus E capital E tau by M, where tau is what? Tau is the average relaxation time. Relaxation time is the time interval between the successive collisions of electrons within themselves as well as with the walls of the container. So that time gap you get when the electrons not collide, then you call it as relaxation time. So this is the formula of Vd, and there's a relation between current and drift velocity, which is I is equal to NeAVd. So N is number density, E is the electronic charge, A is the area, and Vd is the drift velocity. This is a relation. This is a very easy relation, and questions do come from it. You have to remember in this that current is independent of area, whereas drift velocity is inversely proportional to area. Then we had also done Ohm's law. So Ohm's law said that if the pressure and temperature of the conductor remained constant, that all of the current that it is passing through the conductor, that is directly proportional to the potential difference across its end. So V is basically proportional to I, and the constant that you get over here is known as capital R, which is the resistance. So in the last class, we had not gone into the details of what is resistance. In today's class, we'll see what is resistance, what is the property of conductance, property of resistivity, and all these. Question from school. Yes, Salman, just type the question. Shravya, all those J classes coincide with these timings? Okay. Fine. All right. What about others? I want to ask you one thing. You people haven't submitted your assignments. I have mentioned you in the last class that submit your assignments. I think this was the previous assignment that I gave you. See, hardly 5 questions were there in this assignment. Question 1, 2, 3, 4, 5. And question number 3, this we have discussed in the class. Question 4, we have discussed in the class, where time interval was given and we have to calculate the current. All these questions were given. Then why you people have not submitted your assignments? Reason, Hania, you have also not submitted. If you people do not submit your assignments, then how will we discuss it and know wherever you get stuck? At least try to submit the assignments. In all of your batches, whichever batch you belong to, you get the assignment and hardly 5 questions are there. In today's class, okay, after today's class, the assignment that you will get today's class, I'll give you only 3 questions, not even 5, be it 3. But promise that all of you submit the assignment so that we are able to discuss it on Wednesday's class. Will you submit it?
Yes, ma'am.
Yes, teacher.
Yes, please submit it. Otherwise, it will be difficult for you to understand. All the questions are based on what you have studied. Even if you do not get time for self-study, in some other day you are busy with your schoolwork or assignment or something. If you solve the assignment, whatever has been studied in the class, that will be retained. Otherwise, you will forget and you will be needing more of practice, and then calculation errors will be there. So please try to submit. Yes, this chapter you can get backup, Shavya, for this chapter because we haven't done much. Only one class we have done. All right. Now, beginning with resistance. So in today's class, you will complete the previous assignment first. All of you. You should complete the previous assignment. And in today's assignment, I'll give you only 3 questions. 2 or 3 questions I'll give you. But make sure that you do it. So that everyone should do it. Khalid, Salman, Samaira, all of you, Shravya, everyone. Now, resistance. Resistance formula was introduced in the previous class only. If V is equal to IR, then R will be what? It will be simply V by I. V is the voltage, that is the potential difference. I is the current. So R is equal to V by I. Now, if you have a conductor, and you have connected the conductor with a cell with voltage V. Length of the conductor is L, area of the conductor is capital A, and current is flowing through it. Current is flowing through. You have sent an image, Salman. Okay. Okay, I'll see. I'll see. Do one thing, Salman. Send it on the WhatsApp directly, where you upload your messages and all. Okay, then I'll see. It will be better on WhatsApp if I'll check it. Now, before going into the derivation of resistance, just understand also derivation, resistance, what it is meant by. Now, whenever electrons were flowing, what we had studied in the last class, electrons are flowing, they are colliding with the positive charges, they are colliding with the ions, they are colliding with the walls of conductor and everything. There is an opposition to the flow of current. That opposition is occurring with the help of any other thing. Let's say it is occurring with the help of positive charges, or it's occurring with the help of any other thing. The resistance is the opposition that you're getting, all the opposition that you are getting in the flow of charge. Reason can be anything, just the opposition in the movement. Then you call that quantity as resistance. Resistance means the opposition to the flow of electric charges. So now the derivation of it. So we have done a recap already. Hania, you tell me, what is the relation between current and drift velocity? We had derived a formula for it. Even if you're forgetting, look into your notes. You must have written it down. Current and drift velocity. One relation.
I is equal to NEA
VD. Perfect. I is equal to NEA VD. This is an important relation for your numericals as well. VD, don't take it as separate quantities. It's just that D is written in the subscript. I have written it longer. VD means your drift velocity. A is the area of cross section. E is the electronic charge. N is the number density. This is relation between current and the drift velocity. Salman, tell me what is the formula of drift velocity? Just now we have discussed it. Salman. Yes, Salman. Samaira?
minus E tau by M.
M. Perfect. Remember, M is the mass of electron, not the mass of conductor. Even if the mass of conductor is given to you, write the mass of electron only. So it is good, Samaira. It is minus capital E tau divided by M. This is the drift velocities formula. Now, if I just put the value of drift velocity in this, let me substitute it. So current will be what? I will be equal to NEA. Instead of VD, I am writing EE tau by M. And let's not put the negative sign because magnitude is only considered. So it is EE tau by M. So E is getting 2 times, no? So it becomes NE square A capital E tau by M. This is the current's value that I am getting. Now in this EE tau by M, if E is the electric field, let me write for you for it. E is the electric field. Khalid, you tell me, there was a relation between electric field and potential difference. Voltage and electric field. Khalid.
Yes, teacher.
A relation between electric field and voltage, potential difference and electric field. In the previous chapter, we have done this. Try to recall it, Khalid. There was a significance of negative sign in that formula. Anyone else?
E is equals to V by D.
Equal to V by D. Remember we had done this, E is equal to minus dV by dr, where we had seen there was a significance of negative sign. That significance of negative sign said that electric field is directed where potential decreases. So that relation, I'm talking about that relation. So if I write down that relation, then I is the electric field will be V divided by L. V is the potential difference. V is the potential difference. So now put the values of electric field in this formula that you're getting. I is equal to NE square A tau by M. And instead of electric field, write down this formula. Capital V by L. Write down this formula, capital V divided by L. Now see in this formula, NE square A tau divided by M, I have written just V divided by L. V divided by L is what? It's the formula of electric field. I'm not writing negative sign because I'm taking the magnitude only. Just add modulus and take it. So this is the current that we are getting. Now relation between current, voltage and resistance is what? V is equal to IR. So just write current and voltage which you have separate. This is I, this is V that you have. Now all the things apart from V and I will be what? Resistance only. See, V is directly proportional to I. And rest of the quantities that you get, that are the constant, it means that come under resistance. So this is what? NE square A tau divided by ML. This becomes what? This is your resistance. Why? Because V is equal to IR. You have I with you. You already have V with you. So V directly proportional to R. All the constant will be the resistance. So resistance becomes what? Resistance will be NE square. This is 1 by R. So see, what are we getting here? We are getting V is equal to IR, means whatever quantity is left, that is R. So this is I, this is V. It means this quantity is R, 1 by R. So 1 by R is equal to what? NE square A tau divided by MN. From here you have the value of resistance as ML divided by NE square A multiplied by tau. This is the formula of resistance. Now from this formula, you have to understand on which quantities do a resistance depends. Network issues, Ed? Is there any network issue today?
Yes, ma'am. I changed the device.
Okay. So we have just calculated the derivation of resistance today. 1 by R in this manner, Salman. See, I is equal to what? I is equal to V by R.
Yes, ma'am. I have done this derivation.
Okay. So 1 by R will be all thing which is left over here. Now in this, on what things do the resistance will be depending on? The resistance depends on what? From here you can say resistance is directly dependent on length of the conductor. R is directly proportional to L. Second
Area.
one, how area, directly or inversely?
Inverse.
Inversely, good. So R is inversely proportional to the area of the cross section. This is inversely proportional to area of the cross section. Then it is also depends on the nature of material. For different materials, you have different values of resistance. For brass, it will be different. For zinc, it will be different. For glass, it will be different. So it depends on the nature of material. And one last quantity on which resistance depends, that is temperature. Temperature variation, we'll see. You have a whole topic on the temperature variation. So temperature, this is if your temperature increases, then for different materials, resistance will increase, resistance will decrease. Or if you change the temperature, how does resistance change? Then that is studied. You have a separate topic for it. So for now, start noting down these points, and if you have any doubts in between, just ask me. This is the
And is
derivation for
temperature
resistance.
directly related to resistance, or depends on the tau?
Which
Resistance.
is
Directly depends on the temperature, or it depends on tau, how much it increases.
both. It depends on tau. That's why it depends on temperature. Actually, relaxation time depends on temperature. So if you increase relaxation time, if you increase temperature or you decrease temperature, that varies your tau. And because your tau, that is average relaxation time, that gets varied. So that's why you have different values of resistance.
Yes.
So for superconductors, you have different. For conductors, you have different. All right.
Yes.
Salman, till the time others are noting, you hear your solution. See, capacitor 1 is there, capacitor 2, capacitor 3, and capacitor 4. 4 capacitors are connected. If you see carefully, capacitor 2 and capacitor 3, both these are connected in series. So you can take out the equivalent capacitance for C2 and C3. Then C1 and resultant of C2 and C3 along with C4. These three are connected in which manner? Parallel. So you will get the equivalent capacitance for all of them. Once you have the equivalent capacitance, then you can determine the charge and voltage easily. So at these 2 points as well, resistance is a measure of the opposition to current flow in an electric circuit, and the SI unit of resistance is ohm. Just text me done in the chat box when you all have written all these points. Then we'll begin with resistivity. Resistivity is easier than resistance. Once you have understood what is meant by resistance, okay, Zaid, Samaira, Shravya have done. Okay, let's wait for 2 more minutes till the time others complete. All right, so most of you have completed. Fine, so let's begin with resistivity. The derivation of resistivity is very, very easy, easier than resistance. But what is meant by resistivity? The resistivity of any material, it is always defined as resistance, means all the phenomena and the concept of resistance that you have studied. Resistance of a unit length of material with unit area of cross section. If any material has unit area, means 1 meter square area, and unit length means what? 1 meter length. If any material has 1 meter length and 1 meter square area as a cross section, then all the resistance is equal to the resistivity. Why and how? See, so resistance is directly proportional to length. And what I've told you, resistance is inversely proportional to area of cross section. So let me combine these proportionalities. What do I get? Resistance is directly proportional to length by area. By the properties of resistance, I can conclude this, that resistance is inversely proportional to length and inversely proportional to area and directly proportional to length. Now, whenever we have such a case, be it Ohm's law, be it any other law or any other proportionality relation, how do we replace this proportionality sign?
By using proportionality constant.
By using proportionality constant and adding an equal to sign. So in this case, if I add an equal to sign,
Rho.
the proportionality sign that I get is exactly this is rho. Rho is the symbol of resistivity. This is your resistivity. Resistivity. So resistivity, that's why I'm saying, see, just put L is equal to 1 meter, area as 1 meter, area as 1 meter square. What do you get? You get rho is equal to R. So this is the definition. Whenever you have to define anything, just put the constant aside and write down all the things that can be used for unit quantity. What is meant by resistivity? Resistivity of a material is defined as what? Resistivity is equal to what? It's the resistance. So resistivity of a material is defined as resistance of a material of unit length, means the length has to be 1 unit, 1 meter, of unit length and the area of cross section should be 1 meter square. See, if you put it in the formula, then only you'll get resistivity is equal to resistance. So this is and unit area of cross section. This is the unit area of cross section. So this is what is meant by resistivity. Resistivity is what? Resistivity is all the resistance of a material for a unit length for a unit area. Now, the formula of resistivity becomes what? R was equal to rho L by A. So rho can be written as rho is equal to R multiplied by A divided by L. in this manner. Resistance we have already calculated just now. If you remember from here, ml divided by ne square, from here ml divided by ne square a tau. So resistance we already know. This is ml ne square a multiplied by tau. Now we are multiplying it with what? R I have written. Let's write area. Now what is left? In the denominator I have to write length. So area gets cancelled, length gets cancelled. This is not R, this is rho. This is rho. By R was what? R was ml divided by ne square a tau. From here, I have put in the values of resistance and area divided by length. If I multiply, what am I left with? I'm left with m from the numerator and ne square tau from the denominator. This is my formula of resistivity. So it's easy. If you remember the value and the formula of resistance, just delete A and L from it because it is area per unit length. So just delete it. Otherwise, what is that? That is the formula of resistance. Now, if you write down the SI unit of it, SI unit of resistivity. This was what? You can write it with the help of this. Rho is RA divided by L. So we have just done now. What is the SI unit of rho? R, resistance. SI unit of resistance. Look into your notes. You must have written it down. R, resistance. Just check anyone. Yes. Correct. Yes, sure. I have read your answer. Good. It is ohm. Yes, Sarah is also right. It is ohm. So this is the symbol is called omega. The symbol that you write is a Greek symbol which is called as omega. Omega is also written as sometimes W. This kind of curve W, if you remember. So it will be ohm meter. Yes, good, Zaid and Shabir. It will be ohm meter. Why? Ohm for resistance, meter square for area, meter for length. Meter gets cancelled. SI unit is ohm meter. This symbol is ohm. This is meter. All right. So write down this formula and derivations of resistivity. Then we'll move on to questions. At least submit the answer of resistance. How much percentage change will be there in the resistance if the length of the wire increases by 2%? Okay, last 2 minutes for the solution of this question. Try to first find out the new length that you have. First find out the new length that will be there because of increment in the length. Now see, let's discuss it. Let's discuss it. See, if the length of the wire increases, will there be any effect on the area? What according to you is your answer? Should be the answer. Yes or no? There should be any effect on area or not? Yes. What about you, Zaid? If will there be any effect on area? Area will get affected? Yes. See, if I say this was a material, this was a material, it is having the area as capital A, rho is the resistivity of it, its length is capital L. Now I have increased the length. See, volume will always remain constant. So it means from that volume only, the length has to be increased of this material, of this wire that is present. So if the length I have increased in this manner, so let's say this is L dash, this is A dash. So as we are increasing it, as we are increasing the length, the area will become narrower. The area of the cross section, this will decrease. It was thicker earlier, now it has become thinner. So when it has become thinner, now what happens? Area also decreases. So now you have to not only calculate the new length, you have to calculate the new area as well. See, initial resistance will be what? Initial resistance. This will be R is equal to rho L divided by A. And what about the final resistance that you will get? Final here resistance that you'll get, let's say R prime, this will be rho L prime divided by A. Now, yes, Zaid, you are correct. Why are we not focusing on resistivity? Why are we writing only resistance, only resistance? The reason is that resistivity of a material, this is independent of the length and the area of cross section. Resistivity only depends on what? Resistivity only depends on the nature of material. So we'll only calculate it for resistance. For resistivity, resistivity will be the same. There won't be any effect on resistivity. Resistivity will remain the same. Reason for it is that resistivity, this depends on the nature of medium, the material. It depends on the nature of material and the relaxation time also, average relaxation time. Nature of material and relaxation time. So since we have already seen length and area got cancelled, so resistivity, this is independent of length and area of cross section. These are the points for resistivity. That's why for resistivity, you will directly write it as rho only. If your answer is rho, if initially it was rho, then your final answer, it will still be rho. But resistance will change. So let's find out what was the new length, L prime, that I have written in this formula. Over here, what is this L prime? L prime is the increment in 2%. Means L prime is L plus the 2% of length. It has increased by 2%. So whatever ever was the original length plus the increment in the percentage. So L prime will be what? L plus 2% can be written as 2 by 100 of L. So this will be 102 L divided by 100. This becomes 1.02 L. L prime will be 1.02 L in this manner. Sarah, will there be any effect on resistivity in the answer of this question? Will there be any effect on resistivity? Or I'll write resistivity as the same. Sarah. It will be the same. Good. So this is the new length. Now, as we have seen, area will also change. But how to calculate the area? There is no percentage of area given in the question. You have no relation between the area percentage that is changing by 3%, 4%, any amount. Can anyone tell me how can we get area? Percentage change in area. Anything that is remaining constant. Length is changing, resistivity is remaining constant, area of cross section is changing. Apart from these three, any other quantity that will remain the same. Rho is constant apart from this, apart from rho. Yes, resistivity is constant apart from resistivity. Resistivity, length, area, this we have discussed. Any quantity that will still be the same. It's volume. Volume will remain same. Yes, good, Sarah. It will be volume. So volume will remain the same. Initial, whatever is the initial volume, this will still be equal to the final volume. So initial volume was AL, final volume was A prime L prime. Now look at this equation. Only A prime is unknown to you. AL was already known. L prime is now known in terms of L. So write it. A will be A multiplied by what? This will be L. This is equal to A prime multiplied by L prime. L prime is 1.02 L. So L gets cancelled. A prime becomes A divided by 1.02. Now you have the relation between old area and new area and the initial and the final length. Now put it in the formula of the resistance. Resistance formula is what? What is the
Rho
formula?
L upon A.
2L?
Rho L upon
Rho
A.
L, rho L upon. Good, good. So R prime will be rho. Rho will still be the same. L prime upon A prime. So put it the values of L prime and A prime that you have. L was 1.02 L and area was what? A by 1.02. This was the relation that we have seen. L gets multiplied, area is getting divided. So this 1.2 will go up in the numerator since it's in the denominator. So this will be rho 1.02 whole square L divided by A. Now you see rho L by A is what?
Resistance.
Old
It's the
resistance.
old resistance. Good. It's the initial resistance that we were calculating. So R prime is basically 1.02 whole square times the initial resistance that we were getting. Now you can easily check R is what? This is 1.02. So this will be 1.0401 approximately, because 2 square will become 4. Just check it once, anyone. If this is, I have done it orally. Just check it. If the answer is different, it should be around 1.0404 times R. Now you have a relation between old R and new R. This was missing. For this calculation, we have used everything because this relation was unknown. Now you can calculate the percentage change in the resistance. You have the original resistance, you have the final resistance. What will be the percentage change? See, percentage change, if you calculate percentage change in resistance, this is written as delta R by R into 100. Means change in resistance by the original resistance divided by 100. That's how you calculate your percentage. No, change in any value divided by the original value multiplied by 100 gives you percentage. So change in resistance is what? Final resistance minus the initial resistance. That gives you the difference of the resistance divided by the original resistance multiplied by 100. Now R prime is what? R prime is 1.0404 R minus R divided by R into 100. So just subtract 1 from it. So this 1 will go. It will become 0.0404 R divided by R into 100. See, R will get cancelled. This point will come here. It will be 4.04% change in the resistance. So even if it asks you to calculate the percentage in area, same method. Percentage in resistance, same method. Resistivity, no method. Resistivity is simply whatever is the original resistivity. There's a shortcut also. If you get the change in length very less, if the change in length is less than 5%, no, 5% is the minimum value, not above this. Don't use it for often. Then the percentage change in resistance, this will be 2 times x. You will see, for example, our length was what? Change in length was 2%. So percentage change in the resistance was what? 4%. It will increase by 4%. So this is a shortcut. It can help you, but most of the times resistance length change is given above 5%. If it is given below 5% or equal to 5%, not even equal to 5%, below 5%, then you can just double the percentage of length. Directly you will get your answer. So it is helpful for your entrances and your objective questions. Clear? Or this question is clear to all of you? Yes or no?
Yes, ma'am.
No. So note down this. Then we'll do one more question. See, if you have such a question where a wire or a conductor is given and the radius is specified to you, for example, in this question, radius is specified to you. So, Salman, you tell us what will be the area of cross section? Just look at this figure. This is the wire that you have. Yes, Salman. What will be the area of cross section? Salman, are you there in the class?
Ma'am, can you hear me?
Yes, Salman.
Sorry, sir. Sorry, ma'am. Pi r square.
Pi r square. See, area of a circle is what? It is pi r square. What happened, Salman? You got hanged or your computer?
No, ma'am. I couldn't unmute. I don't know why.
Okay. Must be some network issues. See, area of cross section is pi r square if the radius is given as small r to you. So it will be. Yes. So resistance is what? This is rho L by A. So resistance will be rho L divided by pi r square if you have such questions. All right, now note down this question. I am giving you one more question that you all should try yourself. And anyone who gets the answer, just submit your answer. All right, Salman. Okay. All those who have to pray, you can leave. Come pray and join in 5 minutes. So I think all of you are back by now. Let's discuss the solution of it. Were you able to try this question? Did you get the time to try the third question after namaz and all? Zaid, you did? So what's the answer of the first part coming? 1 and 2? Write me your answer, Zaid. All the answers, all the 3 answers. Okay, Zaid, I'll read it. Now let's discuss it. So you have to write the resistivity. Resistivity is rho. You have to calculate the resistance between 1 and 2. See, between 1 and 2, resistance formula is what? Resistance is rho L divided by A. Resistivity rho will be the same for all of the points. It's just the points will determine the area of cross section and that will determine the length. So when we are talking about surface 1 and surface 2, what is the distance or length between surface 1 and surface 2? Between 1 and 2, what is the length? B, L or H?
L.
L.
L. L. Good. It is L. Yes, it's L. So R will be what? This will be rho L. Now, when we are talking about the area of cross section, from here we are calculating. So we'll consider the area of this only. This becomes our cross section. If this is the length, then this is our cross section. Quickly, all of you write me what should be the area of the cross section here for the first part. I have highlighted the area also. Yes, Samaira, good. What about others? Yes, Shravya. Yes, Sarah. Good. It will be B multiplied by H. B is this, H is this. So it will be me multiplied by H. This is the answer of the first part. Second part, surface 3. Actually, I have written it the number of faces that we have. So I was writing with my imagination. This is the front surface. So it appears to look at one face only, but I've written it for different faces. So 3 is the top face. Top face, and 4 is the lower face in this manner. This is the top face and this is the lower face. B will be the length. Length of the conductor will be B. Just check once again between 3. Yes, just check. 3 is the top face and 4 is the lower face. What should be the length? What about others? Only Shravya knows the length. Yes, Samaira, good. Khalid, what will be the length that we'll consider? In this, R is equal to rho L by A. Is Khalid back? Khalid, are you there? I think he has not returned. Sarah, you have written the area of cross section. First, tell me the length. Sarah, tell me the length first. Length will be L, separation between 3 and 4. Zaid, what will be the length? Yes, Shravya, good. Yes, Sarah, now you are right. This will be the answer. Zaid, are you there? Are you back, Zaid? Yes,
Ma'am, can you
Salman.
give me 2 minutes?
Okay, Zaid, okay. So this is rho. Now separation between 3 and 4 is what? H. So rho H. And area will be now 3 surface. So length multiplied by breadth. That gives LB. Similarly, for the 5th and 6th part. Third part means 5th and 6th. 5th and 6th means the top face, this front face and the back face. These faces. So separation between these two faces is what? Chal, good, Salman. Yes, Shravya is also right. Samaira, good. Good, Sarah. So it is R will be equal to rho. Separation is B. That is right. Separation between them. And what is left? L multiplied by H, the area of the rectangle. This is L multiplied by H. All right. So all those who have not written, quickly write it down. Then we'll do something else, other topic apart from resistance and resistivity. Yes, Khalid. Just take the separation as the length and the area of cross section. That will give you. Good. Now we have very small topics. So this was a major topic of your chapter, resistance and resistivity. Now the other topics that we'll discuss now only, right now only, those are apart from these only. If you are able to understand resistance, resistivity, you can easily figure out. See, we have two terms. One is your conductance. Other term is your conductivity. Now it's very easy to remember both of them, conductance as well as conductivity. See, how can you remember conductance or how can you remember conductivity? Conductance is everything that is related to resistance, but just inverse of it. You can even remember from the words resistance, conductance, resistivity, conductivity. So conductance is inverse of resistance. This is inverse of resistance. Whereas conductivity is inverse of resistivity. This is inverse of resistivity. So inverse of resistance, and this is represented through capital G, conductance. This is used in your chemistry as well. In your, you have a chapter with solution electrolyte and something. There's a chapter in your chemistry, electrochemistry, I think. You have a chapter in 12th only. So there also conductance and conductivity, all these terms are used, and everything for related to resistance. So capital G is 1 by R, inversely proportional to R. And then here this is conductivity is represented through the symbol sigma. So sigma is called 1 by rho in this manner. All right, now regarding the SI units of conductance and conductivity. Conductance, resistance SI unit was ohm. So conductance SI unit becomes inverse of ohm. It becomes SI unit. Okay, sir. So this becomes inverse of ohm. That is Ohm inverse, because it's the inverse of resistance. Similarly, it was ohm meter for it, so it becomes SI unit will become inverse of it. Ohm inverse and meter inverse. So these are two quantities that you should remember, conductance and conductivity. You can get theoretical question based on their difference as well, or you can get a question directly on their formula. Majorly questions come from resistance and resistivity portion. From conductance and conductivity, it is not used so much in physics, but you should know, but you should remember the formula of it. Now, two more topics that I've told you, 4 topics we discuss. Conductance, conductivity, 2 are over. One is current density. Current density, this is also an easy topic. All these topics now are lighter and easier than resistance and resistivity is one. Current density is, see, if I say this is a conductor, this is having area of cross section A, current is flowing through it, then whatever current is flowing through it for a unit area, per unit area, you call it current density, represented through capital J. So it is current per unit area. So all of you tell me what should be the SI unit of current density. SI unit. SI unit of J. Tell me, all of you.
Ampere meter square. Let meter is to minus.
Ampere per meter square.
Per meter square. It will be per meter square. Ampere per meter square. Yes. Good. Sarah, Sumaira, Shapya, all good. See, it will be ampere for current divided by meter square. Ampere per meter square. It's a vector quantity. Do not take it as a scalar quantity, because this current is a scalar quantity, but when it comes to be current density, it is a vector quantity. It's a vector. And if it's a vector, then you can easily calculate its magnitude from here simply by using this formula. But what about the direction? It is a vector. Its direction is same as that of current. Its direction is same as that of current. But it's a vector quantity. Do not consider it as a scalar quantity. This current is a scalar quantity. Current is the only scalar quantity that has magnitude as well as direction, but is not obeyed through the vector laws, because it doesn't obey the vector laws through experiment. Scientists have seen, that's why we do not consider it as a vector quantity. But regarding current density, it has been seen. So its direction is same as that of current. Also, you know what? Ohm's law we have studied. What was Ohm's law, Hania? Yes, Hania, in the last class.
At constant temperature and pressure, the current is directly proportional to its potential difference.
Good. V is equal to IR, that is pressure and temperature should remain the same. This is just the condition. Good. Now you have a microscopic form of Ohm's law. Microscopic form of Ohm's law. That microscopic form of Ohm's law, this is established through J. J is what? Current density. J is equal to sigma. Sigma we have just seen, conductivity. J is equal to sigma multiplied by E is the electric field. This is known as the macroscopic form of Ohm's law. This can come in your 1 marker. You don't have derivations on it. It's just that it says that current density means charge that is flowing. Zaid, do you want to say something?
No, ma'am.
Okay. So J is current density. Current density means current per unit area. Sigma means conductivity. Conductivity is everything that is inversely proportional to resistance. So this is conductivity, and E is the electric. So this is about conductance. Now the last topic that I was saying, four easy topics. One is mobility. This mobility, drift velocity you have studied. Drift velocity per unit electric field is mobility. Mobility is related to your drift velocity. Drift velocity, mobility you can identify from the term also. Mobility means what? To move. So drift velocity per unit electric field for a 1 voltmeter or 1 Newton per coulomb electric field, all the drift velocity is equal to the mobility. So per unit electric field. So questions hardly come from mobility as well. We can do the relation between current density sigma and conductivity. Means the microscopic forms of Ohm's law only, no, Zaid? You were referring to that only.
Yes.
So mobility is represented through this symbol, this kind of U, mu you call it. And this is equal to drift velocity per unit electric field. Now see, in this what you need to study? Drift velocity you have already studied. Electric field you have done it so much. In April you have a whole month for electric field. That chapter you had it. So now till we come to mobility, you're already aware of drift velocity and electric field. So that's why this becomes easier. Till here it becomes easier. So SI unit. Yes, SI unit. Yes, that you are going to tell me. SI unit. It's easy. It's easy. Drift velocity is actually a velocity only. Tell me, all of you. Write down the SI unit of yes, SI unit. I haven't received any. Nobody knows the SI unit of drift velocity. What's the SI unit of velocity?
Meter per second into velocity into V.
Meter per second per V means voltage, Khalid.
Yes.
Volt. Meter per second is for velocity. Meter seconds inverse. Meter per second is for velocity. For electric field, volt per meter. Volt per meter you have seen. Okay, meter square per second per volt. Yes, yes. So V is volt only, no? Volt. Khalid, you're referring to voltage only, no?
Yes, teacher.
This V, no? Yes, right. So this meter, when it will go, it will become meter square, then V inverse, second inverse, which you can write it as the way rightly Khalid has written to me, meter square per volt per second in this manner. This is the SI unit of mobility. So these 4 points, mobility, conductance, conductivity, current density, these are easy scoring questions. So this you have written, write it from here. All right, Zed. Others also. If you are done, just text me done. Done or finished, anything. Initially, Samaira, you were submitting assignments. Now you have also stopped. Khalid was also submitting and Salman has also submitted. Done? Others?
Done, teacher.
Zaid, are you asking anything? Okay, so if you all are done, do one thing. I'm not starting any other topic, not the whole assignment. Right now, question number 3, question number 4. See, these are such short questions. It will take such a less time. 3, 4, and question number 5. Quickly do it and send me it on WhatsApp. Submit it on your right now, because you people
Okay.
have not done it. So 3, 4, and 5.
Ma'am, I'll send you after 5 minutes. I'll come back. I have already done this, so I'll send you later.
You have done the assignment, Salman?
Yeah, I will submit it in the website and send you also.
Okay, send it on the make a PDF, all of you, and submit it so that it becomes the checking becomes easier. If Salman, you have done it, submit it right now. I'll see. Okay, you can submit. Then no need of doing it again if you have done. Others, you have 15 minutes, 3 questions.
Ma'am, I'll also submit the assignment. I did it.
You have
In fact-
also done. Khalid? Then
Yes, ma'am,
convert
but I
it.
forgot to submit.
Okay. All those who have done it, just convert it into a PDF and then submit it. Shravi, are you asking it for doubts or something, or for sending the assignment? Shravi, are you asking it for the assignment or just generally?
Ma'am, general, because I was not there during this class.
Okay, I'll give you. Zed, you had received this assignment. This is the first class of current electricity.
And one assignment you have sent before, yeah?
You have attended any class of current electricity?
No, ma'am, but I have done this.
You had received assignment?
Yes.
From the previous batch?
Yes, ma'am.
Okay. Submit. For submission, use that number wherever you upload your assignments and you get your meeting IDs. But all those who are saying that they have completed, you should submit it exactly when your class gets over, means within time period of 10 minutes, because you just have to click pictures and compile it into PDF. Others, right. Salman, the solution of 3 and 4. In this manner, not just by ticking the answers. See, you have to appear for not only objective exams. Objective exams are there for your entrances, but in your board exams, you have to write all those points. No. So even you get MCQs, but you are supposed to write the solution and then the correct answer. All right. So whatever solution, wherever you have done, whether it is rough or not, it's okay for today. Even if it is done roughly, then write it and then submit. Others also, don't just give me the answer and submit A, B, C, or D. I want the solution for the questions. At least for these two, 3 and 4. Salman, are you submitting it again? Are you there, Salman?
Yes, ma'am, I'm there. I'll write
Okay.
it quickly and I'll send it because it's not.
Okay. You have not written it somewhere, roughly or anywhere.
Yeah, I have written it roughly, but
So you can submit it. Submit for today.
I'll
You
just
can.
rewrite again and I'll send
Okay.
it.
Okay. Last 5 minutes left. Khalid and Zaid, you should at least submit your PDS before time. It's okay, you can, because you already have it written in front of you. So Khalid and Zaid, you submit it, and the rest of you also. 5 minutes left. Yes, Shravya, you can leave it. You were not there even in that class when we were discussing it. You can leave. Just take the screenshot of the assignment, or do take the assignment from the team from Learnivio. Take the assignment. Do have the assignment with you. Okay, then Shravya, leave. You can leave. We are just discussing it this only. All right. So we'll see you in the next class.
Okay.
Zed, I haven't received yours. Have you submitted it?
And yeah, I send after this class.
So submit it. Only 2 minutes are left.
Ma'am, is it okay if I send you through WhatsApp?
WhatsApp only. I think better than uploading on it. Just submit it on the WhatsApp, where you get the meeting
Okay.
IDs, the number that you have. Submit it on the WhatsApp. That will be convenient for you all only. Zed, also you submit. Once I'll receive, I'll confirm it to you. Then it will be easier to tally up. I have only received Salman's that PDF where only answers were marked. So that's why. As you keep on submitting, just get it confirmed from me, then you can leave.
Ma'am, I have sent the written one. I guess
Okay.
it is forward yet.
Okay, okay. Have they seen it?
No.
Oh, but you have submitted, Salman?
Yeah, I have sent it to him.
Okay, okay, Salman. Then they'll forward it and I'll see. Others, last 1 minute is left. Try to submit your answers by now. Fifth one was a direct one. Instead of 3 to 5 seconds or 2 to 6 seconds, had it been asking you a single time, like t is equal to 3 seconds or t is equal to 6 seconds, there you would have used dq over dt, means differentiation, and then putting the values of time. Yes, all of you now make a PDF and submit your answers. How much you have done, whatever you have done, just upload it. Otherwise, it will take you only long. And now, from now onward, submit your assignments on time. Make it in the form of PDF and submit it. If you're not able to upload it in on the portal, the Learnivio portal, just submit it on the WhatsApp. That is easier. Making a PDF and attaching the file on WhatsApp. That becomes easier. So today's assignment, I'll give you only 3 questions, but all of you, all the students should be able to solve it and submit it. I'll give you easy questions, but you should do it today only. Don't leave it for tomorrow, otherwise you will forget. Procrastination will never lead you to a solution. Khalid, you have also sent? All those who have sent it to the Learnivio WhatsApp, that also you text me so that I can tally it with them. What about others? Samaira, Sarah, Hanya, have you people submitted it? Okay, Samaira has sent. Okay, Zed. Sarah and Hanya. Sarah, you still doing? So 2 questions were there. Have you done those 2 questions? Whatever you've done, submit it, Sarah. It's okay. Otherwise, it will take a lot of time. And what about you, Hanya? What's your state?
I'm making the PDF right now.